get the same thing. All right, now graphs are sometimes the hardest to find the domain in, or I mean, sorry, the inverse for. So I like to find points. All right, I like to make my own little table. All right, so let's see if I can find some points. So I got this point right here. This is at 0, 1, 2, 3, 4, 0, 4. And it looks like I have, these lines are funny. This line here didn't copy. And this line here didn't really copy. Okay. I got this point right here that is at -2, 0. And this point down here that looks like 1, 2, 3, 4, -4, 1, 2, 3, -4. Oops, you couldn't see my table. All right, so this was the relation. All right, so if I'm going to graph the inverse, the domain, or the x and the y, they're going to switch. So for your inverse, I'm going to graph 4, 0, and 0, -2, and -4, -4. All right, so 4, 0, 1, 2, 3, 4, 0, -2, -4, -4. It's going to have a similar shape, so it's not going to be a line. It's going to squiggle, kind of like it does in the original guy. And so kind of another key attribute of these inverses when you're looking at them graphically is they're going to reflect over the line y equals x. So if you kind of imagine that you fold your paper in half, they should match up like a mirror. Okay, is the relation a function? So the original graph, does it pass the vertical line test? If you were to draw a vertical line, would it ever hit your graph more than once? No. So yes, the relation is a function. And then same thing for the inverse. If you were to draw a vertical line, it would never hit it more than once. So yes, the inverse is also a function. All right, last thing right here, find the inverse and verify using compositions. So when you're finding the inverse here, we are going to switch around the x and the y. So this is going to become x. This is going to become y. All right, this guy becomes x. This guy becomes y. You don't change anything else about your problem. And then we just need to solve for y. So I'm on -6 on both sides. Now over here, don't actually do anything. Just write x minus 6. All right, you can't combine them because that's an x and that's a number, so they're not like terms. All right, so the next thing you're going to do is you're going to get rid of this 2. So the 2 is attached to the y. It is right next to it. So to get rid of that 2, you're going to divide. And if you divide this by 2, you have to divide everything by 2, including the x. Now the understood number with that x is a 1. So I'm going to write this as 1/2 x minus, and then 6 divided by 2 is 3. All right, and so then the last thing is to rewrite that with function notation. And this right here is your inverse. All right, so one last property of inverses, it's kind of a way to check yourself. And if this goes over your head, it's not a big deal. We talked about compositions, I think, maybe, I can't remember. But if you were to take this guy and you were to put it into the x of your original, everything will end up canceling. So 2, 1/2 x minus 3 plus 6. All right, so if you were to distribute, 2 times 1/2 is 1. 2 times -3 is -6. -6 plus 6 is nothing, and so you're just left with plain old x. So if you're left with plain old x, that means you're probably got the right inverse, and you can do the same. You could put f into the inverse, right? 1/2 2x plus 6 minus 3. Oops. Distribute. So kind of same thing, 1/2 times 2 is 1x, 1/2 times 6 is 3. 3 minus 3 cancels, and you're just left with x. So when That's one of the properties of inverses. And so if you have your inverse in your original and you put one in the other, everything will cancel and you're just left with x. And then vice versa, everything will cancel and you're just left with x. So it's kind of a way that you can check yourself, but you're not going to actually have to do that on the test. You're going to have to find the inverse on the test. All right, so that's it for Unit 1. You're going to do Unit 2 tomorrow.